chemical equations. So what are chemical equations? So you can write chemical equation. What is meant by a chemical equation? You write the heading chemical equation. What is a chemical equation? If a question is asked like that, what's meant by chemical equation? Define a chemical equation. So we had seen that when zinc is added into dilute sulfuric acid, zinc sulfate and hydrogen gas are produced, a chemical change. Or when potassium iodide solution is added into lead nitrate solution, yellow precipitate of a lead iodide is formed. That's a chemical reaction we had seen. When magnesium ribbon burns in air, a white powder of magnesium oxide is formed. Another chemical reaction. And all these are the descriptions of the chemical reactions. I repeat, when magnesium ribbon burns in air, it burns with a dazzling white light with the formation of a white powder of magnesium oxide. So there is the long description, narration of the reaction. There's a long narration of the reaction. Similarly, when potassium iodide solution is added into lead nitrate solution, yellow precipitate of lead iodide is formed. A chemical reaction is narrated, a long description of the chemical reaction. Another one, when zinc granules are added into dilute sulfuric acid, zinc sulfate and hydrogen gas are formed. A third reaction, but that reaction is fully narrated. Say we are expressing the reaction in long description. So to avoid these long descriptions of the reactions, we can represent the reaction in a short mode, a short way, a very simple short way. And the short way of representing a chemical reaction in terms of the symbols and formulas of the reactants and products. That's called a chemical equation. So we can write the definition for chemical reaction. You can write the explanation for chemical equation. You right? What's a chemical equation? You write the definition. What is chemical reaction? You right? Short mode. Mode spelling same mode. M-O-D-E mode. A method. A way. A way. A method. So a short mode of representing representing a chemical reaction. Chemical reaction. That is a short way, short form, a short way or short mode, M-O-D-E mode, a short mode, ഒരു രീതി, a method, a way, a short mode of representing a chemical reaction. Representing R-E, P-R-E, S-E-N-T-I-N-G, representing a chemical reaction. A short mode, a short method, a short way of representing a chemical reaction. And what is the short way to represent the reaction? Chemical reaction, comma, using the symbols SYMBOLS. The symbols SYMBOLS. The symbols and formulas or formulae. Formulas or formulae. Plural. Formula singular. Formulas or formulae. E. FORMULAE. Formulae or formulas. So, using the symbols and formulas of reactants and products. Reactants and products. Reactants and products. That is a chemical equation. So, what's a chemical equation? It is a short mode, a short way of representing a chemical reaction using the symbols and formulas of reactants and products. Written. Reactants RE, ACT, ANTS. Products PRO, DU, CTS. Products. Chemical reaction using the symbols and formulas of reactants and products. Say reactants are written on the left hand side of an arrow and the products are written on the right hand side of the arrow. Okay. So we can represent a chemical reaction using the symbols and formulas of reactants and products. That's called a chemical equation. In the chemical equation, when we write the formulas and the symbols, we are asked to equate the number of atoms of the reactants and products. If the number of atoms of the reactants and products are equal, then it is called a balanced chemical equation. So the next point is, what is a balanced chemical equation? A balanced chemical equation. So you can write what's a balanced chemical equation. In a balanced chemical equation, the number of atoms of the reactants and the products are equal. So we have to equate, John, Samuel, we have to equate the number of atoms on both sides, the left side and the right side, the reactants and products. So if the number of atoms of the reactants and products, am I too fast? Can you follow me? Can you follow me or not? Tell me.
Yes.
Right. You can follow. Am I
Yes,
too
sir.
fast?
No, sir.
No, sir.
Sometimes I will go too fast. Explain the things. If you find it very difficult, you would so just to tell me slow down, slow down. Okay, I will slow it down. Okay. So if the number of atoms of the reactants and products are equal, then it is called a balanced chemical equation. So you're right. In balanced, balanced, BALANCED. You must write it. In a balanced chemical equation, in a balanced chemical equation. So what is a balanced chemical equation? In a balanced chemical equation, the number of atoms, the number of atoms, number of atoms of reactants and products, reactants and products, number of atoms of reactants and products are equal, are equal. So the number of atoms on both sides will be equal. Such an equation is called a balanced chemical equation. So another term comes here, balanced chemical equation. So a balanced chemical equation is one in which the number of atoms of reactants and products are equal. Written. In a balanced chemical equation, the number of atoms of reactants and products are equal. Spelling പഠിക്കുക കേട്ടോ. REACTANTS reactants. Products 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 are equal. So the number of atoms on both sides of the arrow, we are going to represent the reaction using an arrow. So number of atoms on both sides of the arrow should be equal. And that is a balanced equation. So we have to write a balanced chemical equation. And what is the principle behind in writing the balanced chemical equation? Why should we write a balanced chemical equation? Why should we have to balance the chemical equation? Why should we balance it? That is in agreement with the law of conservation of mass. Do you remember the law? You have studied the law in the previous classes. You have studied the law. So, balance equation, chemical equation, is based on the law of conservation of mass. Balancing the chemical equation is based on the law of conservation of a mass. So you write as a next point, you write balancing chemical equation. All these are various types of questions asked. Balancing chemical equations, balancing chemical equations is based on, what is the basis? Is based on the law of conservation of mass. Law of conservation of mass. You have studied this in physics. The law of conservation of mass. What is the law of conservation of mass? Do you remember the law? Okay, I shall explain. I shall help you. So balancing chemical equation is based on the law of conservation of mass. So the question may be, what is the basis for balancing the chemical equation? The basis for balancing the chemical equation is the law of conservation of mass. Why should we balance a chemical equation? The answer is that is based on the law of conservation of mass. Conservation of mass. So before going to the law of conservation of mass, let me revise the 3 points again. Let me revise the points. One is, what is a chemical equation? What is a chemical equation? What is the answer? A short mode of representing a chemical reaction using John, say you look at the board. Listen. So, what is a chemical equation? It's a short mode of representing a chemical reaction using the symbols and formulas of reactants and products. Okay, that is a chemical equation. Now, what is a balanced chemical equation? Another question. What is a balanced chemical equation? What is it? The number of atoms of reactants and products are equal. The number of atoms of reactants and products are equal. That is balanced chemical equation. All right? Do you get me? Do you follow what I say? Say yes or no.
Yes, sir.
Okay. So what's a balanced chemical equation? The number of atoms of reactants and products are equal. It's a balanced chemical equation. Now you come to what is the basis for balancing the chemical equation? What is the theory behind balancing the chemical equation? Or why should we balance the chemical equation? That is based on the law of conservation of mass. So there are three questions from here, various types of questions. What's a chemical equation? What is a balanced chemical equation? What is the basis for balancing the chemical equation? The basis is the law of conservation of mass. Now let us see what is the law of conservation of mass. Do you remember what is the law of conservation of mass? Do you remember or not? Do you remember what is the law of conservation of mass? You can write here. Say, mass can neither be created nor be destroyed. Mass, you write the law. Mass can neither be created, nor be destroyed, during a chemical reaction. And that is not only chemical reaction, any change, during any change. So mass can neither be created nor be destroyed. Mass, M-A-S-S, mass can neither N-E-I-T-H-E-R, N-E-I-T-H-E-R. Mass can neither be created, C-R-E-A-T-E-D, nor, N-O-R, nor, neither nor, usage in English, neither nor be destroyed. D-E-S-T-R-O-Y-E-D. D-E-S-T-R-O-Y-E-D. It's not that legible, I think, the yellow color. Can you read it? The yellow color. It's not that bright. It's very difficult. Okay. So mass can neither be created nor be destroyed. That is the law of conservation of mass. Mass can neither be created nor be destroyed. If it is so, during a chemical change, a reactant is converted into a product. A reactant is converted into a product. So the total mass of the reactants should be equal to the total mass of the products. The total mass of the reactants reacting should be equal to the total mass of the products. According to this law, when a definite mass of a reactant is converted into a product, the mass of the product formed should be equal to the mass of the reactant converted into the product. Mass of the reactant reacted should be equal to mass. Mon, John Samuel, you cannot hear me?
Yes, sir, it's
Ah,
okay.
then what is the disturbance there? Okay, it's all right. So, what else? The total mass of the reactants is equal to total mass of the products. Reactants are on the left hand side and the products are on the right hand side. So the total mass on the left hand side reactant should be equal to the total mass of the products formed on the right hand side. Adi Shankaran. Okay. You are bearing a very famous and important and divine name, Adi Shankar, Adi Shankaran. Hmm. Okay, you just study the history of Adi Shankar, Adi Shankar, Adi Dev. Okay, so the total mass of the reactants is equal to total mass of the products, according to the law of conservation of mass. I repeat, balancing the chemical equations is based on the law of conservation of mass. And what is the law of conservation of mass? Mass can neither be created nor be destroyed. If it is so, the total mass of the reactants should be equal to total mass of the products. That's why we are balancing the equation. So as a next step, you write, as a next step, we can write it as, so according to this law, we can write, say, therefore, 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 total mass, you write, total mass of reactants, total mass of the reactants is equal to total mass of the products. Total mass of the products. Total mass of the products. So the mass of the reactants reacted must be equal to the mass of the products formed. That is why we are balancing the equation. Balancing the equation. So first we have to write the symbols and formulas of the reactants and products. Then we have to balance the equation. Balance means we have to say equate the number of atoms of the reactants and products. That is balancing the chemical equation. We can write the word equation also. Instead of using the symbols and formulas, we can write the very names of the reactants and products. If you are writing the names of the reactants and products, then it is called the word equation. We are writing the names as words. So it's called a word equation, word equation. So in the word equation, we are writing the names of the reactants and products. Say, for example, let us take the burning of magnesium. During burning of magnesium, what is the chemical reaction? Magnesium combines with oxygen with the formation of magnesium oxide. So we can write the names of the reactants and products. Then it is called a word equation. So what is a word equation? Word equation. Now, in the word equation, we write the names of the reactants and products. Amina, we are writing the names of the reactants products. Instead of writing the symbols and formulas, if we write the names, the exact names in words, then it is called the word equation. So we have a word equation. So you write word equation, word, W-O-R-D, word equation. What is a word equation? Say a word equation. In the word equation, we write the names of the reactants and products. Word equation. That is names of reactants and products. Reactants and products. Reactants and products. That is the word equation. Reactants and products. That is word equation. But word equation is also a lengthy process. But the symbols and formulas, they are better. Anyhow, we must try the word equation also. So in the word equation, what we do is this. We write the exact names of the reactants and products. Instead of writing the symbols and formulas, we write the names of the reactants and the products. Say, for example, let us take a burning of magnesium. How can we write burning of magnesium using the word equation? What happens when magnesium ribbon burns? There is say dazzling white light and a white powder of magnesium oxide. Magnesium oxide is the product. And which are the reactants? Which are the reactants? The reactants are magnesium and oxygen. That is, magnesium combines with oxygen. So the weight equation is like this. You're right. Magnesium, magnesium plus oxygen plus oxygen giving the product. The product is magnesium oxide. Magnesium oxide. Say in the last class, we had written equation like this. And this is the word equation. We are writing the actual names of the reactants and products. Then it is called a word equation. Say that also will use a large space. So we can convert this into the formulas and the symbols. So let us write the symbolic and the formula equations. Magnesium, you know, the symbol of a magnesium. What is the symbol of a magnesium? Magnesium is Mg, right? Mg, that is the symbol of a magnesium. Written Mg plus. What is the symbol of a oxygen? Oxygen gas. Oxygen gas means oxygen molecule. Oxygen molecule is O2. Oxygen atom is O. Oxygen atom is O. While oxygen gas is O2. Burns in air. In air, there is O2. So the symbol of a magnesium Mg plus oxygen gas O2 giving magnesium oxide. The formula is MgO, magnesium oxide. MgO, magnesium oxide. Magnesium oxide. Mg plus O2 giving MgO, MgO. Now, let us balance this equation. This is not a balanced equation. That's a chemical equation representing the symbols, using the symbols of the reactants and products. Reactants are magnesium Mg, oxygen O2, giving magnesium oxide MgO, the formula. Okay, this is not balanced. And in the balanced equation, what we have to do? We have to equate, we have to make equal the number of atoms of the reactants and products. And what is the method? That is the hit and trial method. It is called hit and trial method. Hit and trial method. We have various methods to balance the equation. There are various methods to balance the equation. Here we make use of the hit and trial method. The thing is this, we are simply changing the number of atoms and finally we'll be coming to the balance equation. That is the hit and trial method. Hit and trial method. We are giving the number of atoms. We are multiplying we are multiplying the symbols and formulas using sufficient number of say the digits, and so that we can equate the number of the atoms. Okay, let us try to balance this equation. Let us try to balance this equation. Very simple equation. Okay, you look at the left hand side. Look at the left hand side. In the left hand side, if you begin from Mg, just wait, Mg, look at the board, Mg, the number of atoms on both sides are equal. Mg reactant 1. In the product, magnesium oxide, in the product, 1 Mg is balanced. So there is no meaning in starting with the balancing with the magnesium. You try with oxygen. Oxygen atoms are not equal. So what you have to do? On the left hand side, there is O2. O2 means two oxygen atoms. O2 means two oxygen atoms. So we have to have two oxygen atoms on right hand side. So to equate the number of oxygen atoms on both sides, you multiply MgO, the formula MgO by 2. Multiply by 2. Okay, that is the hit and trial method. On the left hand side, ഇടതുവശത്ത് ഓട്ടോ മോളിക്യൂൾ അല്ലേ? ആ ഓട്ടോ മോളിക്യൂളിൽ രണ്ട് ആറ്റങ്ങളില്ലേ? വലതുവശത്ത് രണ്ട് ആറ്റങ്ങൾ വരണം പ്രോഡക്റ്റില്. രണ്ടും ഈക്വൽ ആകണം. അത് ഈക്വൽ ആകാനായിട്ട് MgO എന്ന് പറയുന്ന പ്രോഡക്റ്റിന്റെ ഫോർമുലയെ 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക. So to equate the number of atoms on both sides, what we do? We multiply the right hand side MgO by 2. Agar varumbodu there will be two oxygen atoms. Now oxygen is balanced. Okay? Agreed? Padra? Agreed? Number of atoms are equal. Here in 2 MgO, there are two oxygen atoms. On the left hand side O2, there are two oxygen atoms. Now oxygen atoms are balanced. What about magnesium? On the right hand side, in 2 MgO, there are two Mg atoms. In 2 MgO, on the right hand side, John Samuel. On the right hand side, in 2 MgO, there are two Mg atoms. So to equate the number of Mg atoms, we have to multiply the left hand side by 2. Now the equation is balanced. Okay, got it? Written. You must be able to balance the chemical equations. We'll do only 2-3 examples. After that, we can balance the equation. We'll be getting enough chance to balance the equation. Now the equation is balanced. Okay. On the left hand side, 2 Mg. On the right hand side, 2 Mg. In 2 MgO, there are two Mg atoms. Then left hand side O2, two oxygen atoms. On the right hand side, 2 MgO, two oxygen atoms. Now the equation is balanced. Agreed? And the method is called a hit and trial method. We are giving various numbers here and there, and ultimately the number of atoms will be equated, will be becoming equal. That is the hit and trial method. In this equation, it's a balanced equation, no doubt. In this equation, the physical states of the reactants and products are not mentioned. The physical state, solid, liquid, or gas. The physical states of the reactants and products are not mentioned. Magnesium, is it in the solid state? Is it in the liquid state? Is it in the gaseous state? Nothing is mentioned. Only magnesium. Similarly, oxygen is in the gaseous state. In the air. In the air, it is in the gaseous state, no doubt. But nothing is mentioned there. MgO, magnesium oxide. Is it in the solid state? Is it in the liquid state? Nothing is mentioned. So, if you mention the physical states of the reactants and products, then it is called a state equation. State equation. So we can write the solid, liquid, or gas, whichever is the state. Then it is called the state equation. It is called the state equation. Say magnesium ribbon. Magnesium ribbon, that is in the solid state. So on the right hand bottom side, you write S. S for solid. S for solid. Magnesium is in the solid state. You're right? Magnesium is in the solid state. Mg, S. S for solid. S for solid. Then O2, oxygen gas, that is in the gaseous state. So O2G, O2G. Now you come to magnesium oxide. So white powder you got, white powder, solid state. So we can write, say, MgOS, MgOS. The states are also mentioned. In the equation, we are mentioning the states, gas, liquid, or solid of the reactant product. Then it is called the state equation. You are supposed to write the state equation if and only if it is asked. Otherwise, you need not write the states. You simply write the balance equation. If it is asked to write the state symbols, then you have to write S, G, or L. The states also should be mentioned. Okay, so that is called the state equation. We are mentioning the states also. Okay, state equation. Otherwise, we simply balance the equation. That means the number of atoms on both sides are made equal. The number of atoms of reactants and products are made equal. That is the balance equation using the symbols and formulas. Only if the state equation is asked, you can write the state symbols also. It is not compulsory to write the state symbols. If it is asked, you have to write it. Similarly, the word equation. If the word equation is asked, you can write the word equation. Otherwise, you need not write the word equation also. You simply write the symbols and formulas. Okay. Let me take another example for balancing the equation. Another reaction. Same, the reaction of a zinc and dilute sulfuric acid. Do you remember the reaction? Zinc granules are taken in a conical flask. Activity, zinc granules. Granules means solid state. Solid state. Tarigalar, solid state. Solid state. Then dilute sulfuric acid, that is in the liquid state. Liquid state. Then we get a zinc sulfate solution. If it is solution, we write aqueous solution plus hydrogen gas. First, let us write the word equation. Let us write the word equation. So what is the word equation for the reaction between zinc and dilute sulfuric acid? What is the word equation? Which are the reactants? Zinc and sulfuric acid. So we can write zinc plus sulfuric acid. Sulfuric acid. Sulfuric acid. Giving the reactants are zinc and sulfuric acid. Zinc and sulfuric acid. Giving. Which are the products obtained? Do you remember? Last day we had seen zinc sulfate and hydrogen. Zinc, zinc sulfate. Zinc sulfate plus hydrogen. Zinc sulfate plus hydrogen. Zinc sulfate plus hydrogen. That is the word equation. Zinc reacts with sulfuric acid, dilute sulfuric acid, forming zinc sulfate and hydrogen. Zinc, Z-I-N-C, sulfuric, S-U-L-P-H-U-R-I-C, sulfuric acid, giving zinc sulfate, S-U-L-P-H-A-T-E, zinc sulfate plus hydrogen. So that is the word equation. Now, let us write the symbols and formulas. The symbols and formulas for this. Right. Zinc. What is the symbol of a zinc? Zinc is Zn plus. Sulfuric acid. Formula H2SO4. H2SO4. Sulfuric acid. Giving zinc sulfate. Formula ZnSO4. ZnSO4 plus. You write on the right side. You can write on the right side. Plus hydrogen. Hydrogen is a H2. Hydrogen H2. Write on the right side. In the same line you write. In the same line you write. Zn plus H2SO4 giving ZnSO4 plus H2. Symbols and formulas. Symbols, zinc, Zn, hydrogen, H2. Formulas, sulfuric acid, H2SO4, zinc sulfate, ZnSO4. Written? Have you written this? You say.
Yes, sir.
Okay. So that is the symbols and formulas to write the balance equation. Now you try to balance the equation. Aman, Shakir, you try to balance the equation. You try to balance the equation. Equate the number of atoms on both sides. That's all. Aman, try. Come on. You balance the zinc. On the left hand side is Zn. Zn means only one Zn. You look at the right hand side. How many Zn atoms are there? Aman, you say. Unmute and say, Mon. Unmute and say. Huh?
One.
Only one. So Zn and Zn are balanced. Right? Agreed.
Yes, sir.
Left hand side only one Zn. Right hand side only one Zn. It is balanced. Okay. Now you come to hydrogen. Left hand side H2. Two hydrogen atoms. On the right hand side H2. Two hydrogen atoms. Balanced. That is also balanced. What about the SO4? SO4. Left hand side. One SO4. Right hand side one SO4. That means the equation is already balanced. If somebody asks you to balance the equation, immediately you should not start hit and try method by giving various numbers. First you have to check whether the equation is already balanced or not. Say for the examination also, such equations will be given. And you will be asked to balance the equation. The equation is already balanced. So you must check before you start your work, before you begin your work of balancing the equation, you have to check whether the equation is balanced or not. മനസ്സിലാവുന്നുണ്ടോ പറയുന്നത്? ഇക്വേഷൻ ബാലൻസ്ഡ് ആണോ എന്ന് നോക്കിയേക്കണേ, എന്നിട്ട് വേണം പണി ആരംഭിക്കാനായിട്ട്. നിങ്ങളെ പറ്റിക്കും. അങ്ങനെ ക്വസ്റ്റ്യൻസ് തരും, തന്നിട്ടുണ്ട്. അത് ഞാൻ പറയാൻ കാരണം പേപ്പറിൽ തന്നിട്ടുണ്ട് അങ്ങനത്തെ ക്വസ്റ്റ്യൻസ്. ബാലൻസ് ഇക്വേഷൻ തന്നെ ഇങ്ങ് തരും. ആൻഡ് യു വിൽ ബി ആസ്ക്ഡ് ടു ബാലൻസ് ദ ഇക്വേഷൻ. നമ്മൾ ഇരുന്ന് പണി അങ്ങ് തുടങ്ങും. കണ്ടോ? ഒരു പരുവത്തിലാക്കും പണിത്. ഇക്വേഷൻ ഓൾറെഡി ബാലൻസ്ഡ് ആയിരിക്കും. അപ്പൊ ഉടനെ തന്നെ കൊടയും കുരിശും എടുത്തിട്ട് ഓടരുത് കേട്ടോ. ഓർക്കണം, ചെക്ക് ചെയ്യണം whether it is balanced or not. That equation is balanced. ഇതില് the state symbols are not used. The state symbols are not used. If you write the state symbols, solid, liquid or gas, അപ്പൊ അത് state equation ആയി, state symbols. Let us try to write the state symbols also in this equation. Zinc granules, small pieces of zinc, that is solid state. So Zn, yes for solid. State equation. We are writing the state. Zn, solid. It is not sulfur. We are writing it as a suffix. Sudden is, sorry, S is written as a suffix. Right hand, bottom side. Right hand, bottom side. Bottom. Right hand, bottom side. Not in the same line of sudden. Say, I shall show you. If you are writing it like this, sudden yes, that is another compound. Another compound. Here, sudden is sulfur. An element is sulfur. It's an element sulfur. ഇവിടെ അതല്ല here yes is written as a suffix. താഴെയാണ് എഴുതുന്നത്. Not along the same line. Not along the same line. Confusion ഉണ്ടാക്കരുത് കേട്ടോ. Not only that, we are writing the state symbols within brackets also. Within brackets also. In sudden yes, zinc sulfide, we are not using the brackets, but here we have to use the brackets. All right. So sudden in the solid state. Then dilute sulfuric acid. Sulfuric acid is in the liquid state. So that is L suffix suffix liquid state. Zinc sulfate solution. Zinc sulfate solution. If it is a zinc sulfate solution, you can write aqueous. Aqueous. This sulfuric acid in for that also you can write say aqueous. You can write aqueous. That also can be written for sulfuric acid. അതിനും വേണമെങ്കിൽ AQ എന്ന് എഴുതാം. അല്ലെങ്കിൽ liquid എന്ന് എഴുതിയാൽ മതി. Liquid. Sulfuric acid is liquid always. It is liquid. So zinc solid plus sulfuric acid liquid giving zinc sulfate AQ and a dot. AQ with a dot. ഞാൻ പറയാം എന്താണെന്ന് കേട്ടോ. AQ with a dot. Say there was power failure. That was the reason. May we complete this? Time is over, no? Can you hear me or not?
Yes, sir.
Yes, sir.
So we can continue in the next class. That is better, I think. Huh?
Yes,
You
sir.
have written the reaction Zn plus H2SO for giving Zn SO4 plus H2. We can continue from there in the next class. Okay. Do you
Yes, sir.
follow these things? Hmm? Can you follow?
Yes, sir.
Okay. So we can continue in the next class. Thank you.
Thank you, sir.
Thank you, sir.